So, can you discuss a breakthrough application of additive manufacturing that has significantly impacted product design or functionality? I'll start with you, Justin.
Yes, absolutely. So one that we recently showed at Exponential Show, which is a drone show, is from a company called Eye Above, and that particular application is called the Bush Ranger. It's a large drone, about 2 meter wingspan, so relatively large in that space when you start to think of additively manufactured drones. And the purpose of that drone is to monitor and catch poachers. They're based in South Africa. And one way that it's pushed the boundaries of additive manufacturing is over the year plus that he was investigating creating the drone, because the drones that he had access to and were trying to manufacture did not work in the environment in South Africa as far as the wind and the conditions that were there. So we eventually came upon HP, and we worked with them very closely in producing parts that worked over other additive manufacturing, but there's very thin skins on part of the wingspan that are 0.8 millimeters thick. So it was one of those processes where they couldn't, do it manufacturing for the cost that it would be. And there was a huge advantage of being able to do it through additive manufacturing, and about 90% of the parts on the drone are 3D printed. So it's essentially, completely 3D printed. It can be repaired in the field, and it's for a good cause.
I think one of our most recent really exciting areas has been coming out of the whole AI and electronics cooling industry. So we've been working with actually a number of different customers on high performance heat sinks, liquid cooled heat sinks printed in a pure copper material. So I think that historically, pure copper has been challenging to process. It's a little bit difficult to machine. It's a soft material, but it does have sort of outstanding thermal conductivity and other properties. So we've had some success in microchannel heat sinks for high performance cooling applications, where we're able to get lower thermal resistance. We're able to get also better uniformity across the entire heat sink, as well as, I think, the ability to provide sort of a smooth transition from prototyping all the way to manufacturing. So that's something that people have often found as a barrier. They go, okay, I prototyped my part, and then once I've prototyped it, do I then have to switch processes or switch horses to a conventional manufacturing process? And so we've had some success with allowing people to essentially use the same method that they use for prototyping to also scale up to their end final volume needs.